Good day to all students viewing me. I hope you guys are staying safe and healthy wherever you are. In our last topic, we discussed things about solubility curve, where we spoke extensively on the importance of solubility curve. But today, we are looking into a new subtopic under solubility titled Solubility Rules. This is a topic that will teach us how we can determine, how we can predict if a salt is soluble or not. Now, at the end of the topic, I expect each and every one of us to be able to mention examples of soluble and insoluble salt. Then secondly, we must be able to predict the state of a salt, whether it is in solid state or liquid state or aqueous state. All right? Now let's look at the various rules we have in solubility. This is divided into two. This side is the soluble salt, while this side is the insoluble salt. Now, let's look at the rule number one. All salt of group 1 elements, that is lithium, potassium, sodium, cesium, and rubidium, are soluble in water. What we're talking about here is that anytime you have a salt containing lithium, potassium, sodium, cesium, or rubidium, take for instance lithium hydroxide, potassium chloride, sodium sulfate. All these are examples of salts that are soluble in water. So anytime the salt is having the group 1 element, then such salt is said to be soluble. And when you look at the insoluble aspect of the salt, can you see we wrote none here? This means that there is no compound, there is no salt containing any of these group 1 elements that is insoluble in water. All of them are soluble in water. Let's look at the second one. All sorts of ammonium, all sorts of ammonium ions, this is the chemical formula of ammonium ion, are soluble in water. That is, whenever you have a salt containing NH4+, that's ammonium ion, such salt is said to be soluble in water. And when you look at the insoluble part of this, none is written there. That is, there is no salt containing ammonium ion that is said to be insoluble in water. Alright, let's look at the third rule. All sorts of triazonitrate 5 ion, triazochlorate 5 ion, tetraazochlorate 7 ion, we have the acetate, and we also have hydrogen triazocarbonate 5 ion. Or any compound or any salt that contains any of these is said to be what? Soluble in water. While in the case of the insoluble, there is no salt containing any of these that is said to be insoluble in water. Alright, let's look at rule number 4. Okay? All halides, when you say halides, they are halogenated compounds. Any compound that contains the halogen family, those are the fluorine, chlorine, bromine, iodine, and astatine. So, all halides, that is chlorides, iodides, bromides, are soluble except the halide of silver ion, copper ion, lead ion, and mercury ion. So what we're talking about here is that whenever you have any form of halide, maybe sodium chloride or sodium iodide or sodium bromide, all these are soluble in water. But we have some exceptional cases here, whereby probably when you have a sort of halide, like maybe silver chloride, copper chloride, lead bromide, mercury chloride. These are examples of a salt containing this. So whenever a salt is having any of these in it, then such salt is said to be insoluble. But every other one are soluble in water. And that's why we have stated it under the insoluble soil. All the halides of silver, copper, lead, and mercury are insoluble in water. Alright? Then the last one here is all sorts of tetraosulfate 6 ion except the barium sulfate, silver sulfate, mercury sulfate, calcium sulfate, and the lead sulfate. Anytime you have a tetrasulfate 6-ion salt of any of these, they are said to be what? To be insoluble, while every other one is soluble. Alright? Now let's look at, we still have many more of these rules, but when we get to the Google Classroom, we'll discuss more of that. Let's quickly look at the importance of this solubility rule. Alright? Number one, we can use it in qualitative analysis. When we get to probably SS2 or SS3, this is one of the topics you'll be discussing there. This topic will really help you when you get to qualitative analysis. Then secondly, it is used to know the state of a salt. Take for instance, silver chloride. How do we know if silver chloride is a solid? We can easily make reference to, since it contains chloride, can you see this Cl? And we have said that all sorts of chlorides are soluble in water, except for, let's quickly refer back, except for that of silver, copper, lead, and mercury. So that is why, since we have said that the chloride of silver is insoluble, that means that it will remain a solid in that solution. So that is why we have written solid here. That is the state of silver chloride. Then let's look at this again. Sodium chloride. What is the state of sodium chloride? This is a chloride, and let's quickly see. We said all chlorides, that is all allies, are soluble in water, except since sodium is not included in what we have as exceptional cases here. That means that sodium chloride can dissolve in water, and since it can dissolve in water, we use the word aqueous for it. So we have many more examples on this and also on solubility rule. But I will enjoy you students to visit the Google Classroom so that we'll discuss more, because this is just a preamble of what we are still going to discuss in the Google Classroom. So as we listen to this, I pray that God bless us all. Thank you.